Right, hello everybody. Good morning, good afternoon, or good evening, whenever you're watching this. In this video, I'm going to cover the subject of distance time graphs, which is one of the first things we cover on the IGCSE syllabus. Above my head, you can see what I think are the important parts of this little video clip. And basically, we're going to cover two equations, two formulas. The first is average speed equals total distance divided by total time. And the second is we can look at individual speeds, which is given by the distance divided by the time. Distance, we use the SI units for all of these formulas. Distance is measured in meters, time is measured in seconds. So therefore, speed is measured in meters divided by seconds, which is the meter per second. Per means divided by. Okay, so for the purpose of this video, I've made an imaginary journey and shown it as a graph. I don't know what this is. Let's say it's a journey on a bike. Somebody's making on a bike. So first of all, on this graph, I can see that the total journey time was 110 seconds. And I can also see that the total distance travelled over that time was 60 meters. Okay, we can look at the first equation here. What was the average speed during that journey? Well, to find the average speed of the journey, all I need to do is to put the numbers for total distance and divide it by the total time taken. So that would be equal to 60 meters divided by 110 seconds, and that would give us a average speed of, let me write this down. Total distance 60 meters divided by total time 110. That would give us an average speed of 0.55 meters per second. It's very important we don't forget the units, please. Okay, but I can tell a bit more from this graph. I can look at different sections of this graph and see that different things are happening at different points on the journey. In this first orange box, the first section of the journey, we've got a straight diagonal line. In the second section, we've got a flat horizontal line. In the next section, it's an upward sloping curve, and then a downward sloping curve, and then a flat horizontal line again. Now this might be a good point to just pause this video and think if you can work out, before I tell you, what's happening in each section of that journey. Okay, so let's return to the first part of the journey. It's an upwards slope, and we can consider the equation here. Speed equals distance over time, or S equals d over t. Now you should know from maths that gradient is change in the y-axis divided by change in the x-axis. The little triangle represents change. Okay, so we can look at the gradient here of change in y-axis divided by change in x-axis. I've shown that as a red dotted line. But we also know that the y-axis, or change in the y-axis, is equal to change in distance. And change in x-axis here is equal to change in time. So therefore, by calculating the gradient, we calculate the speed. The speed is equal to the gradient because of that equation that we saw before. Okay, so I can put numbers into this equation, into this gradient equation. The gradient, or the speed, is equal to, well, this change. Well, I see that that's 30 minus 0. So that change is equal to 30 meters. 30 minus 0. And I can also see that, coincidentally, the time taken is 30 seconds minus 0 seconds, which is also equal to 30. 30 divided by 30 is equal to 1 meter per second speed. I know because that line is a straight line, it's an unchanging speed, it's constant speed. So between 0 and 30 seconds of this journey, we had a constant speed of 1 meter per second. Okay, drawing the second part here, well, it's a horizontal line. It has 0 gradient, or we could say between that point and that point, there's been no change in distance travelled. So that means there's no movement, or speed is equal to 0 meters per second between those 2 points. Okay, it's a bit more complicated the next section. We've got an upward sloping curve. An upward sloping curve means that the gradient is constantly changing. In fact, it's increasing. If we want to find the gradient at any point there, we put a tangent, a line that's just touching the curve. At this point, that tangent will be given by this distance, or the gradient of the tangent will be given by this distance on the y-axis divided by this distance on the y-axis. Okay, now I can see here we've gone from, well, we've got a distance here from, it looks like 25 meters up to 35 meters. So the change in distance is 35 minus 25. The change in time is, well, it goes from 60 seconds to 80 seconds. We represent that, the difference, as 80 minus 60. 35 minus 25 is a change of 10 meters, and 80 minus 60 seconds is a change of 20 seconds. So I can see here that the speed at that point that I've chosen, this point just where the tangent is touching, we have an instantaneous speed of 0.5 meters per second. Now if I go to the next point, and let's say here, and I put the tangent would be steeper and the speed would have increased. Okay, so therefore in that section, this upward sloping curve, we can see that the speed is increasing, and another word for increase in speed is acceleration. So the bike is accelerating at that point. Okay, then moving on again to the last couple of sections. In this section we can also put a tangent, but we can see that from that point to that point to that point and so on, the speed is not increasing. The gradient is not increasing, the gradient is decreasing as we put tangents at successive points. So therefore, in that section, as the curve is decreasing, or the gradient is decreasing, the bike is decelerating, it's decreasing speed at each successive point. And then finally, that leaves us the last section. The last section is a horizontal line again. So that means that speed is not changing. We have a gradient of 0. So therefore, the bike is not moving for the last 110 seconds. Oh, sorry, the last 10 seconds. Okay, so that's a quick overview of a distance time graph and the application of the equations that we've seen already. I hope it made sense, and when we get to the lesson we're going to put this into practice by drawing our own distance time graphs. Okay, take care everybody, and I will speak to you in our lesson.